In this video, I'm going to walk you through number 2 on the BCA method of mole-to-mole conversions worksheet. So number 2 says propane, C3H8, burns in air to form carbon dioxide and water. If 12 moles of carbon dioxide are formed, how many moles of propane were burned? So let's start with step 1 is to write our chemical equation. So we're given propane and it burns in air. So again, when we see burns in air, that means it's reacting with oxygen gas, O2, to form carbon dioxide and water. So it's forming these. So these are the products, carbon dioxide and water. So take a minute, try and write this balanced equation. Here I have written the unbalanced equation, so make sure yours is correct, and then try and balance it. Pause the video. So I'm starting with 3 carbons on my reactant side and 1 carbon on my product side. I have 8 hydrogens on my reactant side and 2 on my product side, and I have 2 oxygens on my reactant side and 2 plus 1, so that gives me 3 oxygens on my product side. I'm going to start by balancing my carbons. So I have 3 on my reactants. So now I have 3 on my products, but that 3 also affects the oxygen. So that's 3 times 2, which gives me 6 oxygens plus the 1 oxygen from H2O. So now I have 7 oxygen atoms on my product side. So now I'm going to balance my C's are balanced. Now I'm going to balance my H's. I have 8 on my reactant side. So 4 times 2 will give me 8 on my product side. But that 4 also affects the oxygen. So 4 oxygen from H2O plus 6 oxygen from CO2. So that's going to give me 10 oxygen on my product side. And so in order to get 10 oxygen, so my C's are balanced and my H's are balanced. In order to get 10 oxygen on my reactant side, it would be a 5. 5 times 2 is 10. And so now everything is balanced. So step 2 says I need to identify what is given and what I want to find. So when I look at this, if 12 moles of carbon dioxide, so that's what I'm given, are formed, how many moles of propane were burned? So I am looking for the relationship between carbon dioxide and propane, and I'm given carbon dioxide, I'm given how much of that forms, and my unknown is my propane. Okay, so I've done step 2. Step 3 says use coefficients from balanced equation to determine the mole ratio. So here my mole ratio is 1 to 3. 1 mole of propane can produce 3 moles of carbon dioxide. So keep that in mind. And then step 4 is to set up my BCA table and solve it. So I have my before, change, and after. And I don't really care about oxygen and I don't care about H2O. I only care about propane and carbon dioxide because I am given carbon dioxide and I'm converting it into propane. So since carbon dioxide is a product, before the reaction happens, I have no moles of it. And the question is how many moles of propane are burned. So this is my X. I need to figure out how many moles of propane did I start with. Well, for my change, my reactant is going to be negative because that's burning up, that's reacting, so it's going to decrease. And since there's only 1 mole in my mole ratio for propane, it would just be minus 1C. And my product, my carbon dioxide, is being formed, it's being produced, so it's positive, and that's going to be plus 3C. That comes from the coefficient. So then, for my afters, I have X minus 1C needs to equal 0 because all of my propane is being burned. And I have 0 plus 3C needs to equal 12. because I am told that 12 moles of carbon dioxide are formed. So in my first equation, in this equation, I have two unknowns, x and c, and only one equation. So I can't start with that equation. But in this equation, I have only one unknown, c. So I'm going to start by solving for my c. So 3c equals 12. So c would equal 4. 12 divided by 3 is 4. And let's just check that. If we put in 4 for our C, 3 times 4 would give us 12 moles of carbon dioxide. So now I can put in 4 for my C over here. So I'm going to have x minus 1 times 4, which is 4, equals 0. So my x has to be 4 moles of propane. So that's my answer to this problem. Go ahead and try number 3.